For number 2 on 4.2, we are trying to verify that the function satisfies the three hypotheses of Rolle's theorem on the given interval, then find all numbers C that satisfy the conclusion of Rolle's theorem. So the first condition is that f of A is equal to f of B. So if you take your interval, f of 0 means you just plug in 0 into the function and you should get 0. And then if you plug in 5, you will also get 0. So because these match, it means that that satisfies the first condition of Rolle's theorem. For the second condition, f is continuous on the interval. Really, f is a polynomial, and it's really defined on the interval and continuous on the interval. There's no jumps or anything like that. So f is defined and continuous on the interval. The third step is that f is differentiable on the open interval. So we do need to take the derivative. So f prime is going to be equal to 3x squared minus 14x plus 10. Now, this is really not undefined anywhere, or this is defined everywhere. So defined everywhere. So there's no denominator where it could be 0 or anything like that. So this means that it's differentiable, which means we can use Rolle's theorem. So to do that, I'm trying to find a number C in the interval such that f of C is equal to 0. So C, I want to set it equal to 0. So 3x squared minus 14x plus 10 is equal to 0. So I would solve this using the quadratic. So use quadratic. So C, or you could just put x, is equal to negative 14 plus or minus square root of negative 14 squared minus 4 times 3 times 10 all over 2 times 3. So if you reduce this, then it's going to be equal to 7 plus or minus square root of 19 over 3. And if you find the decimal approximations for this, this would be 0.88 and this would be 3.79. So these two values, these are where the tangent line is horizontal. These are the points where where that happens. And you'll notice that the 0.88 and the 3.79 both lie within that original interval of 0 to 5.